Hey guys, Joe back at it once again with some OCR FSMQ. Today we have the June 2017 paper. This is my attempt at the paper. Obviously the mark scheme isn't out yet because it's the current paper, and it's come a little bit late. I really struggled to get hold of the 2017 paper, but I've got it now and I've got it out before results day, which is good. And yeah, hopefully you guys will find it helpful and hopefully you'll have done well. Question 1 then, solve the inequality -2 is strictly less than 3x plus 1, which is less than 7 for 3 marks. Easy peasy, take 1 off both sides. -3 is less than 3x less than 6, which is -1 less than x less than 2. Question 2, find the equation of the line which is perpendicular to the line with the equation 2x plus 3y equals 4 and which passes through the point 3 minus 1. So, rearranging that line, you get y equals 4/3 minus 2/3 of x. Remember that a perpendicular gradient is the negative reciprocal of the normal gradient, so therefore it's 3/2. Y minus b equals mx minus a. We've got a point, we've got a gradient, we put them all in. Times everybody by 2 and you get that, remembering that a double negative equals positive, and take the 2 over the other side and you've got 2y equals 3x minus 11. Quite a gentle start of the paper. Question 3, find the equation of the tangent to the curve y equals x squared minus 3x at the point 4, 4. So we've got a point, we need a gradient, so we use the gradient finder, dy by dx, and that's equal to 2x minus 3. So when x equals 4, dy by dx is equal to 5. Y minus b equals mx minus a. Y minus 4 is equal to 5x minus 4. Expand, tidy up, y equals 5x minus 16. Should really have 10 marks in the bag here. Question 4. The coordinates of a and b are 1, 5 and minus 3, 7 respectively. Calculate the exact length of AB. So we use the length of a line equation, d minus b squared plus c minus a squared, all rooted, which is that. And then that it turns out to be root 20, which is 2 root 5, which is the exact answer. We don't want full calculator displays, we want the exact surd or fraction or whatever it is. So you would have lost a mark if you've cancelled that down into fractions. 2 root 5 is your answer. Find the coordinates of the midpoint of AB, average of the x's, average of the y's. It's a piece of cake. What's the middle between 1 and minus 3? Minus 1. What's the middle between 5 and 7? 6. Question 5. Find the equation of the circle which has its centre at the origin and passes through the point 1, 7. So, what you do here is you realise that the radius is just Pythagoras, because if we draw a circle here, we've got the origin here, we've got this point, 1, 7. You can just draw a triangle to it, and that's going to be 1, that's going to be 7, and that's a line in between. Pythagoras, root 50, which is 2 root 20, no, 5 root 2, yeah, 5 root 2, that's what I'm looking for. So the equation of a circle is x squared plus y squared equals r squared, so therefore we just put 50 in there because it's the origin, so we don't need to put x minus 0 squared plus y minus 0 squared. We just get on with it and say x squared plus y squared equals 50 because it's r squared, so therefore root 50 squared, which is 50. So find the coordinates of the 2 points where the line 2x plus y equals 15 cuts a circle. So rearrange that equation, you get y equals 15 minus 2x. We then paste that into this equation here, and we get x squared plus 50 minus 2x all squared equals 50. Expand that out, tidy it up, and you get that. I say common factor of 5, so divide through by that, and you get x squared minus 12x plus 35 equals 0, and that factorizes beautifully to x minus 7, x minus 5 equals 0. So x is 5 or 7, and then you put that back into this equation to find out your y coordinates, and you find out that they are 5 or 1, so therefore they are your coordinates 5, 5 and 7, 1. fairly gentle start of the paper, I think. Question 6, you were given that the equation x cubed minus x squared minus 10x plus 6 is equal to 0 has two non-integer positive roots and one negative integer root. So using the factor theorem, find the negative root. Don't waste your time using 1, 2, 3, 4, 5. It's told you it's a negative integer. Trial and error, -1, -2, -3, all the way up to whatever till you find a root. And for me, I got -3 as the root using the factor theorem, trial and error. So therefore, if 3 is a root, -3 that should say, if -3 is a root, then x plus 3 is a factor. So we polynomially divide x plus 3 into the cubic, and we go through the motions, and if you don't get 0 at the bottom, you've done it wrong, because what this does is find the remainder, and the whole reason it's a factor is because it's got a remainder of 0. So if you haven't got 0, you've done it wrong. We get this quadratic at the top, and then we stick it next to the x plus 3, and we know that that is the solution, that is it factorized. So now we need to go and solve that quadratic using the quadratic formula, and you get 2 plus or minus root 2. So they are your roots of the equation. -3, 2 plus or minus root 2. So, question 7, find the definite integral between 3 and 5 of x squared minus 7 with respect to x. So what we do here is add 1 to the power, divide by the new power, and then we put 5 and 3 through it and take them off each other like that, and we end up with 56 over 3. So just be careful there with your cubes and your negatives. There's a lot of ways to trip up there, but just make sure you're nice and careful. You've got 2 hours for this exam, so just be nice and careful. Part 2, explain by means of a sketch why the area between the curve y equals x squared minus 7 and the lines x equals 2 and x equals 5 is not the definite integral between 2 and 5 of x squared minus 7 with respect to x. Well, if you draw that curve, you end up with that goes through minus 7, and that goes through, it's about 2.6. I might be slightly off with that, but basically we want y equals 0 because that's when it intersects. So move the 7 over the other side. Root 7 is plus or minus about 2.6. So the nuts and bolts of it is that if you've got lines going through 2 and 5, I think it was, then some of the area is negative. Yeah, it's back here, by the way. That is 2.6, I should say. Anyway, you know what I mean. It's this area here that's negative, and then this area positive. So therefore, that'll cancel out, and you won't get a true area. You'd have to do this area and then add it to this area. Anyway, here we go. 4 ordinary 6-sided dice are rolled. Find the probability that at least 2 6s are obtained. Screaming binomial to me. X can be distributed binomially 4, a sixth. So the probability of getting at least 2 is exactly the same as 1 minus the probability of at most 1, which is that. So the probability of you getting 0 plus the probability of you getting 1, all minused off 1, so they become minuses. So you put those through your binomial distribution formula, and you end up with that. And putting it in your calculator, you end up with 0.1319 to 4 decimal places. 6 marks. I think it could have been a lot worse, a binomial question. It has been in the past, it will be in the future. You should be quite happy. Question 9, then a car moves from rest from the traffic light such that after t seconds its velocity in v meters per second is given by v equals that horrible equation. Show that the acceleration is 0 when t equals 0 and t equals 8. Well, acceleration is the derivative of velocity, so we do dv dt, which is equal to that. Just keep your constant outside. It doesn't affect it. You can expand it if you want, but it really won't help. So yeah, just keep your constant outside and differentiate the t's, and you get that. And then you put a 0 through, and you get 0. And you put an 8 through, and you also get 0. So there you go, you've shown it. 3 marks, quite generous. Find the distance travelled in the first 8 seconds. Well, that's just the definite integral between 0 and 8 of your velocity function, because distance is the integral of velocity. Take your constant outside again, and just keep it there while you're going about your stuff. We did this in the previous question. You put your 8 in, you put your 0 in, you take them off each other. 0 is 0 anyway, so basically just putting the 8 in. And you get 1024, and then you times it by 7 over 128, and you get 56. Now you see why they picked a horrible fraction, because it turned out nice in the end. It always does. Question 10 then. The triangle shown in figure 10 is such that AB equals C, BC equals A, and C equals B. D is the midpoint of the line BC, so that BD equals DC, which equals half an A, and AD equals D. Too many letters, too many similar letters. It's quite a badly worded question, but it's fairly straightforward. Write down a formula for cos ADC in terms of D, B, and A. Well, ADC is that angle there, and we've got 3 sides, therefore it's blatantly cosine rule. Put in your information and you've got yourself a mark. Write a formula for cos ADB in terms of DC and A. Well, that's just simply this angle here, and yet again we've got the 3 sides, so it's just a carbon copy. Using the property that connects angles ADB and ADC, show that D squared is that. So they've given away the big thing here. You may use the fact that cos alpha is equal to minus cos beta if it's on a straight line. So basically you've got ADC, cos ADC is equal to minus cos ADB. So just set them equal to each other and make sure you're negative 1, or change the signs of one of them. Remember, these will cancel out when you set them equal to each other, so you get that. If you tidy that up, you end up with 8d squared is equal to 4c squared plus 4b squared minus 2a squared. There's a common factor of 2, so you might as well divide by 2 now and say 4d squared equals 2c squared plus 2b squared minus a squared. Divide both sides by 4 and you get exactly what the examiner wants, give or take those being in a different order. So in the triangle ABC, where AB equals 9, so that's 9. AC equals 7, so that's 7. And BC equals 10, so that's 10. Find the exact length of the line from A to the midpoint of BC. So what I did here is I worked out the angle ACB, which is this angle here, and I used the information because I had all 3 sides, so I basically just put that into the cosine rule and got 60.9 for this angle here. And then for the midpoint, remember that this side is 5 and we're wanting this line here, so it's cosine rule again, but remember we want the side this time, so a squared equals 7 squared plus 5 squared minus 2 BC cos A, and we've just worked out what the cos bit is, and that leads to a squared equals 40, so A is 2 root 10. Quite a nice question. Don't worry if you didn't get all of that, because it is quite niggly, and yeah, I wouldn't be surprised if a lot of people drop marks on that, just because there was a lot of similar letters and a lot of margin for error. Not a lot of margin for error, I should say. Question 11 then. So a farmer conducts a trial on plots of land to decide what amounts of fertiliser will yield the greatest crop. He knows that if he uses no fertiliser, then he gets 24 tonnes per plot. He finds from his trial that if he uses 2 kilograms per plot, then the average yield is 34, and if he uses 4 kilograms, he gets 32. All the plots in the trial have the same area. So he uses some weird equation, and yeah, we have to show that C is 24. Well, we're told that when he uses no fertiliser, he gets 24 tonnes, so we set 24 equal to the thing with a 0 put through, so it's 24 equal to C, so C's a 24. 1 mark. Using the data above, show that Y is that. So for 2 kilograms of fertiliser, we put a 2 through and we set it equal to 34, and that leads to 18 equals 4A plus 2B. And then for 4 kilograms of fertilizer, we've got 32 is equal to 4 put through it, and you get 36 is equal to 8a plus 2b once you've fiddled around with it, divided through and deliberately matched the b's. You'll end up with that. Then solve the simultaneous equation, so you get 18 equals 4a. Divide both sides by 4, so a equals 9 over 2. And then put that 9 over 2 back through one of the equations, and you get 36 equals 36 plus 4b, so b is a 0. Because the 36's cancel out, you've got 4b equals 0, b must be a 0. So putting that information back into this thing up here, we know what c is, we know what a is, we know what b is, so it's y equals minus x cubed plus 9 over 2x squared plus 24, which is exactly what the examiner wanted. So using calculus, find the amount of fertilizer that should be used to maximize the yield and find the yield for this amount of fertilizer. So we want to find stationary points, so we're going to differentiate and set equal to 0, so that's exactly what we do. And because there's no constant, we can just rearrange that and get 3x equals 9, which means x equals 3, and then we put that back through our y function, and we get minus 27 plus 81 over 2 plus 24, and that's 37.5 tons, and 6 quite easy marks at the end there. Considering they've given you this, I think 6 marks is very, very generous. Question 12, linear programming. There's lots of information in there. School wishes to transport students and teachers, totaling 300 people to a concert. It uses a coach firm that can provide minibuses which can seat 10, or coaches that can seat 30. The coach firm has 15 minibuses and 8 coaches that it can hire out. Let X be the minibuses, let Y be the coaches. Write down an inequality in X and Y that must be met in order to transport the students and teachers. So 10x plus 30y is less than or equal to 300 because you can get 10 on each minibus and 30 on each coach, and you've got 300 people to seat, so that's blatant. And then you divide through to get x plus 3y is less than or equal to 30. State 2 more inequalities regarding the maximum number of vehicle that can be hired. Well, the coach firm has only 15 minibuses, so x must be less than or equal to 15. And it's only got 8 coaches, so y must be less than or equal to 8. So there's 2 nice easy marks for you. It costs £100 for a minibus and £150 for a coach. The school's got £2,400 to spend. Write down another inequality, so it's 100x plus 150y must be less than or equal to 2,400. Cancel that down, you get 10x plus 15y is less than 240. So plot the 4 inequalities on the grid provided. You should shade the region that does not satisfy the inequalities. Now, I didn't have any graph paper for this, so I did a very, very rough sketch, and basically I've scanned it up so you guys can see what my thought process was. I've said it was a bad plot, but you get the general idea. You've got a little section down here. It's not quite to scale because I've basically drawn it myself, but if I had graph paper it would look a hell of a lot better. And yeah, that's the general look of it. One teacher suggests that the best arrangement is to hire as many minibuses as possible. So if you have a look at the graph, you can see that 15 is possible, and there's only 15 coaches allowed. So we go up to there, and then I worked my way up to the first sort of corner and went along and thought that was about 5 because it was higher than halfway, which would have been 4, so yeah, 5. So that's what I went for there. Might not be right, but that's what I thought. And then the organizer decides to basically minimize the costs. So you could have done objective function where you would have done 100x plus 150y is equal to p, and then you would have sort of picked a friendly number, probably 300, worked out x and y, drew in an objective function, and sort of took that out that way. And the first time you hit a point is your minimum, and I basically did trial and error of all the points here and worked out that produced the lowest costs of £1,800. So that's 6 minibuses and 8 coaches. So sorry it's not 100% correct probably, but it gives you an idea of the thought processes. Just have a little drink there. Question 13. A path AB crosses a section of moorland in an east-west direction. John wishes to walk from A to point C, which is due north of O, on the path AB. A is 4 kilometers due west and C is 3 kilometers due north. On the path he can walk at 5 kilometers an hour, and on the moorland he can walk at 2. So 5 kilometers an hour is a kilometer per 12 minutes, because basically we're working out the time from C if he goes along from A if he goes along the path and then up the moorland. So it's 1 kilometre per 12 minutes. There's 4 kilometres to walk on the path, so it's 4 times 12, which is 48 minutes on the path. On the moorland, it's 2 kilometres an hour, so 1 kilometre every 30 minutes. There's 3 kilometres to walk, therefore it's 90 minutes on the moor. Add them together, 138 minutes, or 2.3 hours, something like that, or 2 hours 18 minutes, whatever you like for that one. Direct from A to C across the moor, so draw a little line in there, and that's a right angle triangle, so that's going to be 5 because of Pythagoras. 3 squared plus 4 squared equals 5 squared. Root that, it's 5 kilometers, so that's a 5, and it's going to be 30 minutes per kilometer, so it's going to be 5 times 30, and it's going to be 150 minutes, which is 2.5 hours. So, John finds that he can minimise the time to walk if he sets off towards O on the path, but at a distance x. So if we say that that is x, he turns and he sets off. So basically that's x. That's then going to be 4 minus x, this little length here, from here to here. And then you've got a little right angle triangle. So find an expression for the time he takes to complete the walk. So it's always going to be x over 5 minutes on the path, because speed equals distance over time, so time equals distance over speed, and he walks 5 kilometers an hour on the path, and he walks a distance x. For this bit, I'm going to call the sort of slope bit y, and do Pythagoras on it, and you end up with that. Once you've expanded and tidied up, you get y equals that. So basically that's the distance you'll do. So therefore your time will be distance over speed, and he walks at 2 kilometers an hour on the moorland, so it's going to be that over 2 minutes on the moor. So your time is going to be the minutes on the path, add the minutes on the moor, which is that. So using this expression and by substituting values in for 2.6, 2.7 and 2.8, show that there is a justification for x equals 2.7 being the distance. So basically what you do is just a test in calculator skills really. You put a 2.6 through and you get a t to be that. You put a 2.7 through and get a t to be that. You get a 2.8 through and you get a t to be that. And therefore t is the lowest when x equals 2.7. 3 marks is ridiculous for that, although getting this is worth more than 4 marks, I think. So the last question of the paper, and it's a stupid one. I'll let you read it if you want. Pause it now. Oh no, I'll read it. Why not? L side can be modelled by a prism A, B, C, D, E, F. I know the alphabet. As shown in figure 14, ABCD is a horizontal rectangle and DCEF is a rectangle in the vertical plane. BCE and ADF are right angle triangles in the vertical plane. The angle of the slope EBC is equal to FAD, which is equal to 28 degrees. AB and DC and FE are equal to 1000. EC and FD are equal to 200. John sets off. John again. He's off on one. He's walking again. He sets off from B, walking up the line BE to a point X, where BX equals 100. He then walks across the slope directly to F as shown in the diagram. Y is on FD such that XY is horizontal. Now that'll come in big a little bit later. Find the height X above the baseline BC, so that's that line here, which I've kindly drawn for you there. We know that that is X, we know that that is 100, and we know that that's 28 from the question. So basically putting that into trigonometry, X is equal to 100 sin 28 or sine 28, therefore x is equal to 46.95 meters. Nice easy starter. We've now got to find the length fx, so that's the sort of slope bit here, which is that. So I drew another right angled triangle and I said that that's 1,000. So what I'm thinking of here is that that's E, that's F, and that's X. So then what I said is that EB is 426, which is this line here, which is equal to 200 over sine 28 because we've got the 200 there and we've got the angle. So I did some trigonometry to work out what EB was. So therefore EX must be 426 minus 100 because that's just that bit there. And that's going to be 326, which is that. And then it's simply just a case of Pythagoras for fx, which is that. So it's 1051.8 meters for fx. Part C then, hence calculate the angle of the slope of the line fx. Well, we use our knowledge that this line is horizontal, so this line here must be equal to the height that is above because that is horizontal. So YD is equal to 46.95, so therefore FY is equal to 200 minus that 46.95, which is 153.05, so that's FY, which is up there. And then we work out this angle here, and we do a sine to the minus 1 job because we've got the opposite and the hypotenuse, which is fx. So it's 153.05 over 1051.8, and it turns out to be 8.37 degrees. So that is the June 2017 paper. Disclaimer, you know, this is my attempt at the paper. There might be some incorrect answers in there. If you want some clarification, let us know down in the comments. If you found it helpful, make sure you do leave a like though. It does mean a lot for me and helps out the channel a lot as well. Make sure you share it to anybody that you know has done this paper this year, and to anybody that's doing it in the future. And yeah, hopefully it's been helpful for you. I think it was an okay paper. It was better than last year in my opinion. But there's quite a few questions where you could have tripped up on. Make sure you let us know down in the comments what you think you've got for this, and next Thursday or the Thursday after, whenever you get your results, let us know exactly what you got for FSMQ. I'd love to hear it. Very best of luck for whatever you're doing post 16, whether it's sixth form, apprenticeships, getting a job. Best of luck for that, and very well done for doing the FSMQ. It's a tough course to do at GCSE, but if you're doing A-level maths, it'll really help you. So very well done for that. Hopefully you found this video helpful, and yeah, I hope everybody's having a wonderful day and a wonderful summer. Thanks for watching, and goodbye.